In this video, I will discuss about RS-485 serial communication standard. RS-485 serial communication standard is having wide advantages. So, it supports long distance communication and it supports multi-drop. Because of this standard is widely used in industries. Some of the serial communication standards are RS-232, 423, 422 and 485. Out of these, RS-232 and RS-423 is a unbalanced communication, which means the signal is transmitted with reference to the ground. Whereas RS-422 and 485, these are balanced communication, which means the signal is transmitted as a differential signal. Because of this, these standards will support longer distances compared to the other two standards. RS-485 standard is most versatile of all the four RS interface standards, and it is an extension of RS-422 standard. So this RS-485 will support same speed and distance as RS-422, but what is the difference? So RS-422 is support one driver and 10 receivers that can be connected on the same bus, and RS-485 whereas supports 32 drivers and 32 receivers can be connected on the same bus. Here we can see these are the so many devices are connected on the same bus. PLCs, drives and the remote IOs are connected on the same bus, and all the same devices are having RS-485 serial communication feature. And along with this RS-485, so for addressing these devices, so which device need to take the data, which device need to take the control action. So for that some protocol need to be specified. So here we can see this is a CC link protocol, which is a field bus, so that using the RS-485 as the physical layer. So many other field bus protocols use RS-485 as a physical layer for the transmission of the data. So some of these field bus protocols are Modbus, Profibus, CC-Link and AS interface. This is some of the protocols that uses RS-485 as a physical layer standard for sending the data in the serial way. RS-485 standard defines multi-drop network connection on the same 2 bytes and allows serial data communication for distance up to 1200 meter. So and this distance is the same as that of RS-422, and data rate will support up to 100 Mbps, and it is also same as RS-422. And here is the difference compared to RS-422. Here it supports 32 line drivers, whereas RS-422 supports only one, and here it supports 32 line receivers, whereas RS-422 supports only 10 line receivers. This is the unbalanced communication. So how it happens? This is RS-232 and RS-423 is this unbalanced serial communication. Here you can see, so the data is transmitted with reference to the ground and also received with reference to the ground. Because of this, so it cannot be used for longer distances, because in industries so much noise will be present. So because of this, so the noise may be added to the signal line, and so it will give an erroneous data. So in order to overcome this disadvantage, so balanced communication is used. So this RS-485 and RS-422 is using this balanced communication. Here the signal is transmitted as a differential signal. Here we can see A and B. So this is differential signal. So and this is transmitted, and the receiver end is also a differential signal. So the noise which is adding to both the wires will be cancelled out at the receiver because it's a differential signal. Here we can see how this device can be connected in the multi-drop. These are the two wires. So this is the one device, so that is the master, and there are the other devices are slaves. So the same wires are connected like this, so which will extends the devices. That depends upon the protocol, and this is known as DC chained connection. So this connection is known as DC chain connection. So like this we have to connect the device in multi-drop in RS-485 serial communication standard. So now we are seeing the voltage levels of these signals. So if the line is A, here this is the driver and this is the receiver. If the line A is more positive than line B, that is VA minus VB is greater than 200 millivolts, then at the input of this receiver, so here it will be logic 1. And similarly, if line B is more positive than line A, in that case VA minus VB is less than or equal to minus 200 volts. In that case, the receiver output is of logic low, and this is with respect to the receiver. So what is the driver voltage? So here if it is 1, so the driver voltage VA minus VB should be greater than or equal to minimum plus 1.5 volts, and it can go up to maximum 6 volts as per the standard. And similarly, if DI is 0, so in that case VA minus VB is less than or equal to minus 1.5 volts, that is minimum. It can go up to minus 6 volts as per the standard. And here you can see, so the driver voltage are plus 1.5 volts to minus 1.4 volts for logic 1 and logic 0. These are the minimum voltages. And at the receiver end, so this is plus 200 millivolts and minus 200 millivolts are the logic high and logic low. And this plus or minus 200 millivolts is known as the sensitivity of your receiver. And this is here we can see this is the voltage levels. So minus 200 to plus 200 is the undefined state, undetermined state for the receiver, and above 200 millivolts it is logic 1, and below it is logic 0. So the major enhancement of RS485 is that it can support 3 states, that is logic 1, logic 0, and another state is the tri-state. And this is the tri-state is the high impedance state that made this RS485 to be operated in the multi-drop operation. In multi-drop operation, so whenever if the driver is put in high impedance state, so it will not draw any current, and it is not present on that line. So each terminal in the multi-drop system must be allocated a unique address to avoid conflicting with other devices on the system. Suppose if there are 10 devices connected on the same bus in multi-drop way, so each device should have a specific address so that the master can address a particular device, so that the particular slave will give a response to the master query. And also RS485 includes a current limit in case of any contention occurs, means in case of any collision occurs. The half duplex communication of RS485 device is shown here. So suppose if we consider this as a master and this as a slave, and these are connected by using a single twisted pair cable, and because of this both the data cannot be transmitted and received at the same time. The first master has to send a response, and then only the slave will give the response, and master has to listen to that response. So for both the transmission and reception of the data to happen at the same time, so we have to use full duplex communication. In that, so separate twisted pair cables used for transmission of the data and the reception of the data. Here we can see these are the truth table for transmitting the data, that is for the driver. Here if the driver is enabled with the DE, that is DE equal to 1, and if we put a logic 1 at the DI, in that case so the A will be high, the line A will be high compared to B, and as per the standard this A minus B is greater than or equal to 1.5 volts, and it can go up to 6 volts. And similarly if we put a 0 when the DE is enabled, so in that case B line is high compared to A line. In that case A minus B is less than or equal to minus 1.5 volts, and it can go up to minus 6 volts as per the standard. And this is truth table is for driver, and this is at the receiving end. So this is the receiving end. So means this slave is giving responding to the master query, and it is sending the data. In that case, so this RE is a active low. If it is 0, then this will be enabled. And if it is receiving a voltage in this lines A minus B, whenever it is greater than or equal to 200 millivolt, then this RO is 1. And similarly if it is less than or equal to minus 0.2 volts, but it is 200 millivolts, so in that case so this RO will be 0. So this figure shows how multiple nodes are connected in half duplex communication in RS485 standard. So this is one node, so this is second node, and this is third node, and this is the fourth node. So all the nodes are using the same twisted pair cable. And this figure shows how these multiple nodes, that is different nodes, are connected in full duplex communication as per the RS485 standard. So separate twisted pair cable is used for the transmission of reception of the data. And this is the comparison chart of the different RS serial communication standards. You can see this is RS485, so this is a mode of operation is differential, and number of drivers and receivers is 32, and the recommended length is 1200 meters, that is 4000 feet, and the data rate that supports is 10 Mbps, and the common mode voltage is -7 to +12 volts, and the driver output signal, it is minimum ±1.5 volts, and maximum it can go up to ±6 volts. And this is the driver load, so resistance should be of 60 ohms. And here we can see this is another important parameter, the receiver input resistance, it is greater than or equal to 12 kilo ohms, and if this 12 kilo ohms is increased to much higher value, so the number of devices that connected on the this bus can be further extended. Means it is 32 as per the standards if we keep 12 kilo ohms, and if the resistance is increased, the number of devices, that is 32, will be increased further. And the receiver sensitivity is ±200 mils, which we have discussed earlier. So because of it, so many advantages of RS485 standard, so this standard is widely accepted in industry for serial communication. Thank you for watching my video.